talk that I kind of put together because I see people who are otherwise, really good forensicators, and they get handed an image of a Linux system, and sometimes they come down with what I think of as the Linux fever. They get a little pale, they get a little sweaty. They're not really sure what to do or where to get started, and they kind of hope that if they look bad enough, somebody will say, "Oh, here, let me look at that for you. I'll take care of it," right? So I just wanted to put together a quick presentation, which was the important places to start looking when you're handed a Linux image and trying to get some basic profiling information for what's going on with the system, how it's configured, what the users might be doing, and also some places you can look for persistence mechanisms that may have been left behind by an attacker or other signs of malicious activity on the system as well. The slides are available from my website. The URL will be at the end of the presentation if you didn't see me posting it on Twitter. Why do people, why are people uncomfortable about Linux systems? Obviously they're different from Windows, which is 98% of the systems you're probably going to deal with, at least from a physical computer perspective, not a mobile device. So Linux has a lot of things that are very different from the way we do forensics traditionally on a Windows system. Not the least of which is that you don't have a registry, right? So all of the things that you're used to pulling out of the Windows registry using RegRipper or whatever your favorite registry analysis tool is, are all scattered all over the place on Linux systems. Now there are a few directories on Linux where those configuration things get concentrated, and we'll talk about where you start to go looking for all this stuff. But you kind of have to create a list for yourself of basic configuration files that you need to look at. Obviously, you're not dealing with NTFS anymore on a Linux system. You're probably going to be dealing with some version of the ext file system, but you may be dealing with something even weirder like Riser or JFS or something like that, which a lot of the forensic tools don't even deal with. ext, is different from NTFS in a lot of respects. There are no file creation dates, which drives a lot of forensicators up the wall about Linux file systems, until you get to ext4, which does start having creation dates. So there, on a traditional Unix file system, there isn't really a way to look at a file and say, when was this file created? The other thing is that when files are deleted in modern ext file systems, most of the important metadata about the file is zeroed out, and that makes file recovery on ext3 and ext4 a lot more difficult. There's some presentations on my site about recovering ext3 file system data, which I talked about at the last SANS DFIR summit. So I'm not going to go into that here, but you can find pointers to that on my website. The nice thing about Linux, though, is that most of the data you're going to deal with is, 95% textual. And so string searching, looking for artifacts that way, is usually pretty easy. A lot of the text is structured. It has timestamps and things like that that you can search for. So, recovering Unix log files tends to be pretty easy because you can sort of search for the timestamp patterns and things like that. So it's actually, I find it a lot easier to carve and things like that on Linux as well. Also, Linux files are null terminated, so it's easy to kind of find the end of a file just by looking for a big chunk of nulls at the end of a block. So that also makes carving much easier on Linux file systems. Getting access to the file system itself can be complicated, and I've written a whole bunch about accessing Linux file systems through, encryption, logical volume management, Linux RAID, and all that stuff. And I really didn't want to rehash all that here because that's multiple huge presentations in and of itself. So I'm just going to refer you to the stuff I've written on the SANS Forensics blog and presentations I've done, like at CEIC, which you can get from my website, which you can see on the slide there. Hey, Malia, for carving on Linux, I generally use Foremost. Scalpel is another tool you can use. Good heavens. I'll have to take your word for that on the COBOL files. If the COBOL files are text files, they should be null terminated. That's the Linux file system standard. So, all right. So let's talk about kind of important places to know about on the Unix file system. So this is basic file system orientation, right? So the /etc directory, generally referred to as /etc on Linux systems, is where the bulk of the system configuration data lives. And if you want to, you can think of that as the sort of registry equivalent for Linux file systems. So all of the kind of basic system profiling data that you'd be used to pulling out of the registry hives in system32 config probably lives in a file somewhere under /etc. I just threw up in my mouth a little bit relating Linux file systems to the Windows registry, but anyway, you get the idea. So there's a bunch of files under there that we'll talk about that are worth looking at. The sort of equivalent of Windows event logs is the stuff that lives under var log in the Linux file system. And there are lots of different logs, and the names of the logs can vary depending upon the flavor of Linux that you're looking at. But generally, there'll be a file under there that's called messages, which is sort of all of the kind of crucial system information. There'll be a log called auth-log or varlog secure, which contains records of logins and access to administrative privilege and things like that. Also, we'll typically track automated tasks and things like that. And then all the stuff that you're used to looking at under user home directories, the user profile directories under Windows, like documents and settings or /user for Windows 7. The Linux convention on that is generally /home/username. That can vary, but that's the sort of standard location. But different sites may choose to put their user home directories under other path names. You can figure out the home directory for the user by looking at the password file, which we'll talk about in just a minute, though. So the log files in Unix are just text files, and so they can be truncated. Data can be deleted from them. Yes, I can change the timestamps in the file if I wanted to. And that is sort of one of the downsides of dealing with Linux forensics, is that most of the things in the Linux operating system are mutable, and if an attacker gets administrative privileges on the box, they can do whatever they want to do. Basic system profiling stuff. I mean, this is the stuff that you're used to pulling out of the software and system registry hives on Windows, right? So, like, what version of the operating system am I running? Most of the Linux distros seem to have settled on this convention of creating a file called etc something-release. Okay, so on Red Hat systems, it's etc redhat.release or -release. On my Ubuntu laptop, it's etc lsb release. On the whiteboard here, I actually, cut and pasted some command output. We're actually having some difficulty doing screen sharing to my Linux box, so I'm cut and pasting command output onto the whiteboard. So you can see, there's this etc lsb release file on my Ubuntu system, and when you look at the contents of it, it's like, oh, look, I'm running Ubuntu 10.04, which is the last long-term support release for Ubuntu. JJ, uname doesn't actually show you the version of the Linux operating system. It shows you the kernel version and some other information like the processor architecture, but it doesn't actually say that, this is a Red Hat system or this is a Ubuntu system. And knowing those things is actually useful to you, because knowing what flavor you're on tells you where to look for certain other files or what files you should expect to see. The other thing that is sort of troubling to most people about Linux systems is there's no artifact in Linux that tracks when the system was installed. You can't, look at a file and say, it says, I was installed on blah, blah, blah. So you have to come up with some sort of proxy to figure out when the operating system was first installed. And what most people will commonly do is look at the timestamps on the SSH host keys, which are normally created when the operating system boots for the first time. The SSH startup script creates those files automatically if they're not there, which they're typically not when you first install the OS. Now again, the problem is that somebody could maliciously go in and jump on the timestamps for those files, but that's kind of the common proxy for when was this system installed. But it's not there's no guarantees there. You're just making an assumption based on those timestamps. Usually the name of the computer is stored in a file called etc hostname. The etc hosts file may have the hostname in it as well. Also, Unix log entries that you find under var log will typically contain the hostname. So if you look at the logs, you'll see the hostname on every single entry. And then where do you look for IP addresses? Well, it depends. I mean, if the system is configured with a static IP address, that static IP address will typically live in your etc host file. But if it's a personal system like my laptop, for example, that uses DHCP, you need to find where the DH client application on Linux stores its lease configuration. And this is also variable. So varlib DH client is a common location. I think on my Ubuntu system it's actually somewhere else. Let me go looking for that. ls varlib. Yeah, so on my Ubuntu system it's varlib dhcp3. The neat thing about Linux systems is that they'll typically track every time the computer gets a new lease, there'll be a new file created under whatever directory. So, for example, I'm staring at my varlib dhcp3 directory on my Ubuntu systems, and there's literally about 4 or 5 dozen files for timestamped, which show me what IP address my computer had from boot to boot to boot. So that's pretty useful. Usually, the DHCP client will also create log entries under var log when it gets a new lease as well. So you might be able to find those as well. Time zones on Unix are kind of problematic. There's this file under the etc directory called etc local time, and it's a binary file. And so you can't just look at it and say, this computer is configured to be in the central time zone where I am now, right? So you have to use some sort of extra intelligence to figure out what time zone that etc local time file represents. There are a couple ways to do it. If you're doing your analysis from a Linux system, then there's the zdump command, and you can run zdump, give it the argument etc local time, and it will show you what time zone that time zone file is using. So if I quickly run zdump here on my etc local time file, and I'll just cut and paste this into the whiteboard for you so you can see it. Oops. This is not the text you're looking for. never mind. It basically gives you output like the date command, but it shows you the date relative to the etc local time file. So zdump is useful for that if you happen to be doing your analysis on a Linux system, which I do because I'm a Linux guy, but you all might be using Windows. The alternative is to take an MD5 sum over the etc local time file and then look for files in the Linux time zone database that share that MD5 checksum. So the Linux time zone files live under user share zone info, and you should be able to find a file with the same MD5 sum as the etc local time file on the system you're looking at and figure it out that way. The files under user share zone info are named things like US Eastern or Bogota or whatever, so you'll be able to figure it out that way. So talking about the user account database on Linux, it lives in two files. There's this etc password file which stores all of the public information about the user, like their home directory, their full name. The full name field might contain other data like a phone number and even an email address, depending upon the site policies. The other half of the user database is the etc shadow file, which stores private information that's only available to the administrator, which includes the MD5 hashed versions of the user's password. If you want to know the user's password, you'll have to brute force it using a tool like John the Ripper. The other thing you ought to know is that in Unix, any account that has the UID 0 has administrative privileges. Now, normally there's only one account in the Linux password file that has UID 0 associated with it, and that's the root account, which is the super user account for Linux. But after root compromises, you'll often see attackers putting in extra UID 0 accounts for themselves and trying to hide them in the middle of the password file. And there's a sort of canonical sort command that you can type that will actually sort the password file by UID. And I can actually type that sort command. I do it so often that I remember it. So it's sort minus K 3, which means we're sorting on the third column of the password file, which is the UID field. We want to do a numeric sort. The delimiter in that file is colon, and you do that on the etc password file. And at the end of the day, what you get is the password entries in UID sorted order, so all the UID 0 accounts will bubble right up to the top of the password file. The other file that you might want to look at is the etc sudoers file. So sudo is a utility like runAs under Windows to execute commands with administrative privileges. And the sudoers file tells you which users are allowed to do what commands with elevated privilege. That sudoers file is often written in terms of Unix group memberships. So, certain members of certain groups are allowed to use the sudo command. So you can find information about group memberships in the etc group file. Now, when you hear group memberships, you might be thinking about groups in the Windows group policy sense, and Unix groups are not at all like that. Unix groups are very, very limited. So, oh, my bad. Can everybody see that command now? So in any event, yeah, when you hear Unix groups, don't think group policy, because it's really not like that at all. Getting a list of who's logged into the system. The canonical place where that's stored in Linux systems is this var log wtemp file, which is one of the few files that you're going to run into in Linux that are actually binary and not textual data. Actually, I'll put the command up right now while I'm talking, because you don't need to see this slide right now. So the wtemp file is binary data, and you need to use a special command to unpack it, and that command is the last command. So you run last -f, and then the name of the wtemp file, which is usually varlog wtemp. So command goes like this. Oops. Last -f varlog wtemp. And you may want to add the -i option, which will list the IP addresses of the remote hosts that are connecting in rather than their host names. Generally, I find the IP address is more useful. Last, we'll give you the user logins in reverse chronological order. It also shows you when the system was rebooted and other useful information like that. You can also find information about user logins in other log files in varlog, like varlog secure or varlog offlog. Those files also track information about when users su to root or use the sudo command. The sudo command also has its own special log file, usually varlog sudo log or something like that, which will show you what users are running what commands at what times. So that's also really useful auditing information, particularly if you have some sort of root compromise issue. So users have their own configuration data, and that configuration data lives in home username typically, except for root. Now root's home directory is /root, so you'll need to look there as well. There, and we'll talk about using files under /root as a persistence mechanism for attackers. So it's definitely a place you want to look. The tricky thing that Linux does is there's this Linux convention, it's actually an old Unix convention, that any file name that starts with dot doesn't show up when you just ls the directory. So you'll find most of these configuration files starting with dot at the front of their name. So there's like a dot profile, dot bashrc, which configure the user's shell. There's a dot bash history file, which stores commands that the user has typed and things like that. A lot of these files contain commands that may be executed either when the user logs in or runs a particular program, and so they can often be used as persistence mechanisms or way for attackers to get a backdoor onto the system. So let's talk about some of these user artifacts. So web browser artifacts, right? Everybody's interested in what everybody's doing on the web. Now the good news is that Linux users tend to use the same browsers that you find on Windows. Firefox and Chrome are common on Linux, and those browsers use the same artifacts as they do on Windows. So it uses the same SQLite databases, and so you can use the same forensic tools that you used to using on Windows for unpacking web history. You just got to know where to find those artifacts on a typical Linux system. So they live in the user's home directory, and you can see on this slide the common path names for where you find the profile directories that contain the SQLite databases. But once you find them, they're just like the SQLite databases that you're used to dealing with on Windows, and the tools from Nersoft or your favorite forensic toolkit can unpack those artifacts no problem. So really, once you find them, just like Windows, you're good to go. Linux systems have a graphical file browser that's kind of like Windows Explorer. It's called Nautilus. Nautilus keeps track of stuff that the user does. Now, I'm a command line guy. I don't use Nautilus all that much. But for people who are new to Linux or people who are uncomfortable with the platform, they use Nautilus a lot. And Nautilus tracks what the user does. So, for example, when you go into a directory in Nautilus, just like in Windows Explorer, it'll show you thumbnails of documents. It'll show you thumbnails of image files in the directory. It doesn't create thumbs.db files in the directory like Windows does. Instead, Nautilus keeps all of its thumbnails under one directory in the user's home directory called .thumbnails. And so you can go into that directory and you can see thumbnails of, files and directories that the user has visited. It's really, really useful. Nautilus also keeps track of files that the user opens by double-clicking in the Nautilus interface. So that goes into the recently used .xbel file. It's an XML formatted file that tracks files opened, what time the file was opened, and also what application was used to open the file. So this is all stuff that you're used to pulling out of, the registry keys in the user's ntuser.dat file. That stuff all lives in recently used XBEL, at least for Nautilus. So if the user goes through the Nautilus interface, you'll find those artifacts in that file. And again, that's useful for showing intent, right? The child porn wasn't just downloaded by my cat walking across the keyboard. I actually visited these files and looked at them repeatedly and things like that. So good information. For people who use the command line like I do, there's a file called .bash history. Yes, Malia, I just compared Linux artifacts in the registry again. And yes, I just threw up in my mouth a little. So there's bash history, which tracks the commands that the user types. Now again, it's just a text file, and it can be deleted by the user, it can be edited by the user. In fact, there are configuration settings that completely turn off command history, which, if I'm going to be hacking into a Linux box, the first thing I'm going to do is turn off command history. And yet, having said that, I will tell you that having done analysis of a large number of Linux systems in my life, it is amazing to me how often the bad guys don't actually blow away their command history. Maybe you only catch the stupid ones, but in any event, the command history is very useful. The downside is that there are no timestamps in the command history, so you can't say for certain when certain commands were executed. Although I found it possible to relate certain commands in the command history to artifacts in the file system. So for example, you see a command in the command history where the user unpacks a zip file or a tar file or something like that. That leaves behind artifacts in the file system. And you can sort of look at those artifacts in the file system and say, this command probably happened at this time. And from there, you can kind of have an idea of when the other commands around that command might have happened as well. Again, there's nothing 100% certain in that, but you can make some pretty interesting guesstimates based on that information. I need to write up a white paper about that in my copious spare time. But it's really interesting trying to match up commands in the command history to file system artifacts. That can be productive. So if bash history gets deleted, I very often find the bash history in unallocated, because even when the attacker deletes the bash history, they don't securely delete it. They don't use something like shred that overwrites it. And the bash history itself is pretty easy to find because you'll look for SSH space, right? People SSHing and SCPing to various directories, or cd space /, right, which is a common command, right? cd to the /etc directory or something like that. Searches like that can often find the command history for you. So speaking of SSH, SSH is the standard remote login file transfer mechanism for Unix systems. There are SSH artifacts in the user's home directory that you ought to know about. So for example, there's this file called known hosts. That file is a list of public keys from systems that the user has connected to from this system. So you can use that to show places that the user connected to. It doesn't tell you that the user actually successfully got logged in, it's just that they connected. Authorized keys is the file of public keys that people use to log into this system. After a root compromise, you may find attackers putting extra public keys into the authorized keys file as a backdoor mechanism. But you can also use the authorized keys file to relate to data you find on another system that says, hey, this user had the public key that I found in the authorized keys file on this system in their home directory over here, so probably they're related, right? The ID RSA are the key files. So there's ID RSA.pub, which is the key you put into the authorized keys file, and then there's ID RSA, which is a usually encrypted secret key file, which you use as the other half of the login. Yeah, Ty, in general, when you're looking for stuff in Linux, you have to have at least some notion of the structure of the file or common strings that you would look for in the file in order to find it. I mean, there's some exceptions, like the wtemp file that I talked about. That actually is a structured binary file, and you can there are ways that you can look for the binary signature of that file. But in general, yeah, you're looking for text, and you got to know what the text is going to be, right? So, yeah, Corey, the wtemp file will show people who've connected to the system remotely. Also, varlog secure is right, or varlog auth log. Those are also files that will typically track SSH connections, inbound SSH connections. All right, so that's kind of basic profiling, right? How to find out about the system, how to find out what users are doing. But what if you have a Linux system that gets compromised? What are the leave behinds that you look for after a typical Linux compromise? Backdoors from the attacker, persistence mechanisms for the attacker's tools, other crazy stuff that you should look for, et cetera, et cetera. So persistence mechanisms. All right, so basically the attackers are looking for places where the Linux system commonly starts programs from. Usually they want their tools to start up at boot time whenever the system reboots. Now, on Windows, right, you're looking at the current version run keys and the service keys and things like that. On Linux systems, you're looking at the scripts that get executed by the init program when the system reboots. Traditionally, on Unix systems, those scripts live in directories like etc init.d or etcrc.d. However, there's this new thing that's starting to appear in Linux distributions. Ubuntu, newer versions of Red Hat are using this thing called upstart, which changes the way services are started at boot time. And so they have their own configuration directories. Usually the etc init directory contains the scripts. Well, how do I know whether the attacker has added something or not? Well, okay, so if you're not using something like Tripwire that will tell you if the files have been modified, the easiest thing to do is to just compare the scripts against the scripts from a known good version of the same operating system. So if you have kind of a gold master copy that you work from, you can just do a comparison between the scripts after the exploit and the scripts before and figure out what happened. Unix has a utility called diff, which makes it really easy to compare two files and see the lines that are different. There are other places where programs can start. So Unix has scheduled tasks just like Windows. We call them cron jobs. The startup scripts for cron jobs are in either etc cron something or var spool cron, and they're typically lots of different script files that you'll need to look at. So one common persistence mechanism is to modify either a cron tab file directly or one of the scripts that's being called out of cron to start up the attacker's tools. So you'll want to look at those as well. Great Lakes Techie, is anybody actually using systemd as part of the base Linux operating system? I don't know of a distro that's actually using it. Yeah, well, Dan Bernstein can keep his startup scripts wherever he wants to, but I'm not playing. All right, so looking for backdoors, common backdoors include Trojan versions of common services. SSH is a common example. But really, anything that listens on a network port can become a backdoor for an attacker. We've seen Trojan versions of TCP wrappers, binaries, and other crazy stuff like that. Web shells are another common one after a web-based exploit. You see attackers putting up the PHP script that allows them to execute arbitrary commands remotely. There are lots of those that are available. I mentioned adding extra UID0 accounts in Etsy Password and Etsy Shadow as an administrative access, but you'll also see people just activating new accounts as a backdoor, including there are a lot of accounts in the standard Linux password file that are sort of role accounts for particular applications like MySQL and things like that, and those accounts are normally locked, but one common backdoor is to unlock one of those service accounts and allow logins via that mechanism. I mentioned the authorized keys file. These are keys that allow people to log into the local system. Attackers will often create brand new authorized keys entries as a backdoor for certain accounts. Also, if your Linux system is still running one of the network super servers like inetd or xinetd, then those are also services that can start other services, potentially a backdoor for an attacker. Modern Unix systems tend to be going away from those inetd type services, but you'll still find them on some machines, so you'll need to look at the configuration files for those as well. Several years ago, Ed Scotus put together a couple of little PDF files that you can find on the SANS website, the intrusion discovery cheat sheets, and one's for Linux and one's for Windows. And Ed puts a whole bunch of useful commands on there. These are supposed to be cheat sheets that you hand out to your sysadmins and operations staff so that they can look for signs of a potential compromise. And those cheat sheets are a pretty good starting point for a checklist of things that you should look for after a suspected root compromise. So, some of the things that those cheat sheets look for are listed on this slide, like set UID and set GID files that didn't exist before, or programs that have been set to set UID or set GID that weren't previously. So the set UID mechanism in Linux allows elevated privileges. When an executable is set UID, that means that it runs with the privileges of the owner of the binary rather than the person executing it. So, for example, there are programs like the password program under Linux. Users need to be able to change their password, which means modifying a file that's normally only accessible to the administrator. So the password program is set UID to root for certain limited things. Other things to look for, directory names that start with dot. Now, this will generate some false positives because, of course, you have directories like .ssh, but one of the common kind of rootkit hiding mechanisms is, oh, let me create a directory called dot space dot or something like that the administrator might not notice. Now, frankly, I don't know why they do this, because it makes it really easy to find their rootkit directories, right? Because directory names starting with dot are not all that common in Linux. So if you just get a list of them, the malicious directories pop right out. Similarly, you'll see attackers putting rootkit files under /dev because it's a big, complicated directory. But most of the files under dev are regular files, not regular files. They're device files, right? So you can just do a find under dev looking for things that are regular files, and I can actually put that command up for you here as well, although it's on the cheat sheet. But this is just one of those standard commands that you end up memorizing if you do enough Linux analysis. So you do a find starting in /dev looking for things that are regular files, and the command looks like that. You'll get some false positives with the dev udev directory, and curse the Linux kernel developers for deciding that putting this database of removable devices under dev was a good idea. But this is a useful command for looking for sort of common rootkit installation directories. Let's see. Other things that you ought to look out for. any files that have been recently modified. I mean, yes, attackers, once they break root on the system, can change the timestamps, but frequently they don't, right? So I just had an incident not too long ago where attackers broke into a Linux box. We knew the time of the break-in from the network-based IDS. It was the night before. I did a find to show all of the files that have been modified in the last 24 hours, and boom, all of the attackers' files just popped right out. So, yes, the attackers can modify their timestamps, but often they don't. And I don't know what to say about that. Also, large files in Linux are just not that common because it's mostly a text-based operating system, right? We don't have a lot of big Word documents and things like that running around. So just doing a find for files that are, say, larger than 10 megabytes can be a fruitful way of finding things like packet sniffer traces and other malicious data that may have been left behind by the attacker. All right, so I'm done. Here's all of the contact info for me if you have any questions. I've written a lot of blog articles about Linux forensics on the SANS Forensics blog, so if you follow the link to the articles that I've written, you'll find a whole bunch of Linuxy goodness there. You can also follow the link to where I'll be teaching next for SANS. I'm going to be doing the reverse engineering malware course for SANS coming up in April in the DC area. So any DC area folks, we still have some seats open for that class if you hurry and register now. Steve, Linux memory analysis. Yeah, so Linux memory analysis, let's talk about that. It's primitive. Really, really primitive. The first thing is actually getting a memory dump out of a Linux system. A couple of years ago, the Linux kernel developers broke the dev mem device intentionally so that it's not easy to dump memory. You need to bring in a basically replacement version of dev mem so that you can dump the memory out of it. So there's a open source package called fmem that you can use for dumping Linux memory. Fresponse will dump Linux memory. You know, there are commercial memory dumping tools that will work as well. Or, you know, if it's a VM, you just dump the .vmem file from your VMware instance. So first off, you have to figure out how to get a memory dump, which can be tricky. Once you've got the memory dump, there's a sort of fork, if you will, from the volatility project of people that are working on a volatility port for Linux. It works for a couple of Linux kernel versions, but I've had intermittent luck at getting it to work for all kernel versions. Now, clearly it's being worked on, and I've been flipping some emails back and forth with Andrew Case trying to get better volatility support for Linux. So it's coming. It's not here yet. But you should still be taking memory dumps on your Linux system, because by the time your case gets to court, we should have a working volatility for Linux, and you'll be able to analyze those memory dumps. So don't let the lack of good memory analysis tools for Linux right now dissuade you from taking memory dumps when you do your forensic captures. Please do take memory dumps. At worst, you can just do string searching in them right now, but volatility support for Linux is just around the corner. It's really, really close, so we'll be able to do it soon. What percentage of clients observed with Tripwire installed? Yeah, or some sort of file integrity assessment tool. It depends on where the thing is. In large enterprises, particularly in the financial sector, very common to find file integrity assessment tools being run. In the cloud, or kind of startup type West Coast computer engineering companies, not so much. And so you're left with either going to their backup tapes or building a pristine operating system from source to get sort of a known goods that you can compare against. Obviously, the NSRL databases don't tend to track Linux files, so you're left kind of building your own. I mean, it's easy enough to do. It just takes time to set up a Linux system and create the hash database. Books on Linux forensics. There are a couple. They haven't been updated in a couple years. The ones I've seen are just okay. Rob Lee has made me promise to write a Linux forensics class for SANS, which I'm going to get to just as soon as I finish this case I'm currently working on. Of course, that's been going on for 2 years, so who knows? But yeah, I need to, write a book or a course on this. Yeah, screw you, Rob. Okay, so Rob is not believing my promise to write the Linux forensics class, and who can blame him? Other questions before I get out of the way for Corey? As far as databases of known good Linux MD5s, so for example, Sun publishes this thing called the Solaris Fingerprint Database, which allows you to track Solaris MD5s. The Solaris Fingerprint Database is pretty cool, and I hope Oracle doesn't kill it off. I think Red Hat published something similar. The other thing is that you can look at the package database on a Linux system, so the RPM database on a Red Hat system, for example. That includes checksums over all the files. So you can, for example, if the attacker hasn't modified that database, do an RPM-V to verify the checksums on the files in the file system. And that's often a useful technique for detecting unauthorized modification. So, alrighty, I'm done. Corey, well, let me throw it